I'm recording again. Did it ask you about recording? Now I'm recording. Okay, so you've all come from different places, different backgrounds, and a lot of what we're going to do is knocking the rust off. Because being college algebra, it's a lot like Algebra 2 was in high school back in the days. And we probably all have seen everything we're going to do. And one of the things is we just have to knock a lot of rust off. So I'm going to try different strategies. I'm going to say things different ways sometimes from what you've heard before to try to help make sense. But hopefully as we go through this, you're going to be going, yes, I remember how to do that. Nope, that's Greek to me. I have no idea what's going on. So this first section, 1.1, you know, and again, the language of math is linear equations. Linear, that's a line, right? We all know that's a line. But a linear equation, more well-defined, first of all, it's linear. And linear means, as you see down here, there's only one unknown. And the most popular unknown is X. And as we go through the course, there's going to be a lot of times I'm not going to use X. I'm going to use other things. But X, so it's linear. That just means one variable. Equation, When I see the word equation, what's that tell me about down here? There's going to be, the screen is so blurry, I can't see much. Is that true for everybody? Yeah, it's blurry for me too. Sorry about that. Were you able to download the sheet 1.1? Let me do this. Is that better or worse? Sounds like the doctor's office. Is that any better? Yes or no? Nina, no, it's no better. Okay. I have some buttons, but let's go. Is that a little better? Is that a little better? Anybody? Nina, talk to me. Is that better?
It's a little better.
A little better. One of the things make sure you do is up in the upper right-hand corner, it says view. Make it speaker view so you see the whole screen. But we'll do the best we can. I'm not sure why my camera's blurry today. Normally it's not. But I'll fix it. Okay, so we're going to do some of these little equations because it has an equal sign. That's why it's an equation, equal sign equation. We're going to go through and solve it. And you're going to remember all of the things you need to do. And a lot of that is that, you know, I need to get rid of the parentheses. This meeting is being recorded. Yes, it is. I need to go back to that, you know, clear the parentheses, please. That was the parentheses. You know, please excuse my dear Aunt Sally or whatever it was, you know, and the order of operations as we go through here. So when I get ready, I'm going to go and you know, okay, somebody have an answer for this first one. Solve for X. Solve for X. I'm going to get rid of the parentheses first. And yeah, this is a big Facebook thing now. People put this on to try to mess you up and see what values you get. But I'm going to go through and I'm looking at X plus. I'm going to take that 4 and I'm going to distribute it, right? I'm going to multiply it through. So it becomes 4x minus 20. Again, I'm going to distribute through 4x minus 8. Taking a look at that, we now want to, the document, yes, thanks, Nina. Now what am I going to do? I'm going to combine like terms over here. Well, I have variable unknown terms and regular terms. So 5x minus 20. Over here, I still have the 4x minus 8. Then I'm going to get the That's about as simple as I can get right now. So now I'm gonna subtract 4x, x minus 20 equals -8. Add 20. I got x equals 12. Anybody else? Daniel, yeah? You got that as well? Yep, x is 12. All right. Folks, if you have questions, you have to speak up or I'll just keep going. Understood? If you slow me down, I'll slow down. If not, I get excited. So you're gonna have to gauge me. All right, so hopefully some of you got excited after number 1. And while I was talking, you already started to do number 2. And I'm going to give you a couple seconds, see how far you get on number 2. That's the nice thing about having these notes ahead of time. You can print them out and go through some of them. And, you know, okay, yeah, I already know how to do this before class even meets. Now, this one's a slight difference because I have to distribute not 5, but -5. Some like terms over here. Some like terms over here. 1 and -15 is -14. I have a question. Is 0 an answer possible? I see you all nodding your head. Yes, it is possible. All right, I'm going to add 20x and add 20x to both sides. 16x minus 6 equals -14. All this work of combining like terms. 16x equals, I have -8. Something we didn't have to do last time that we have to do now. Right now, this is 16 times x. So I'm going to divide by 16. X equals -1/2. How many of you believe that's the right answer? If you were a perfectionist, Daniel, what would you now do? You're muted. I said, if you were a perfectionist, what would you now do? Plug it in to check it out, right? Yeah, perfectionists will do that. The rest of us go, oh yeah, that's right. I got an answer. It looks pretty good to me. I'm moving on. Don't want to run out of time. Anybody have an answer for number 3? Look in the chat. Nope, no answer yet for number 3. Same kind of idea. Parentheses first. .2 times 5. That's the same as 2/10 times 5. That's 10/10. That's 1. So 1x minus 1.6. I'm going to add, let's see, add x and add x. And again, that's 1x and 0.6 gives me 1.6x. What might some of you do at this point? Because you
add 1.3 on both sides.
Yep, some of you may add 1.3. That is a definite option. And I'm hoping that's what all of you do. Another choice is I could clear the decimal. I could, this goes into the 10 commandments of mathematics. What someone does to one side of an equation, thou must do it to another. And if I multiplied this side by 10, I'd have to multiply this side by 10. And we'd multiply everything by 10. Ryan, why would I multiply everything by 10? To get rid of the decimal points. Yeah, but I'm not afraid of decimals. 1.6x equals negative 0.3. Maybe I'm afraid of, let's multiply this side by 10, this side by 10. That gives me 16x equals negative 3. Yeah, I'm not so scared of it now. And I'm going to divide by 16. X equals negative 3 over 16. Yeah, no. Did I mess up anywhere? Did I mess up anywhere? Somebody say yes. Well, let's go through and double. Go ahead.
Wouldn't we subtract the x?
Yeah. No. I wanted to see who was watching. Yeah, I messed up. We should have subtracted x. Okay, and does the video and his voice keep lagging for anyone? Sorry about that, Ryan. Yeah, we should have subtracted an x from the very beginning. And I apologize, we missed it and nobody else spoke up, so I don't feel so bad. There's 21 other people. We should have started out by subtracting an x. Process is still the same. All of the things we did here, practicing wise, is what you need to do. And again, one of the things is, should we clear the decimal by multiplying both sides by, in this case, 10, so that moves it over 1 decimal point. All right, so I messed up. We're going to let that one go. You got the idea of what's going on. Can't hear you very much. Sorry about that, Emma. Okay, try number 4. It's the internet connection. Yeah, I think it's on my end. Okay, so this time I have, instead of decimals to mess with, I have fractions. And when we were talking about decimals, we said we can multiply everything on both sides by a number and distribute it through. Well, I can do the same thing here, multiply everything by a number, and I mean everything, to help me clear that denominator. Does anybody remember what I multiply by? Well, I need something that when I multiply it by here, will cancel with the 3. When I multiply it by here, it'll cancel with the 6, and it'll cancel with the 2. What number
would it be for 2/3? Would you multiply the denominator by 1/3?
No. I'm looking to clear it. Right. Ryan says it's the LCD. It's the least common denominator. It's the number that will cancel with all these. And in this case, it's going to be 6. So if I was to write and say, I'm going to multiply everything on both sides by 6. Okay? If I take 6 times the first term, I get 12 thirds x, which I'm going to be able to reduce. Okay. Jandy, that's going to be in a situation like this. If I say 1/6 x equals 9, this is when I multiply by the reciprocal, because 6 times 1/6 gives me 6/6, which gives me 1x, which we know is just x. So that's when that situation would occur. Okay. So I'm multiplying by the reciprocal. Another one might be if I say 2/3 x equals 9, I'm going to multiply, since this is 2/3 times x, I'm going to multiply by 3/2 on both sides. Okay? So it's when I want to clear the coefficient, the number in front of the variable. Great question. I like questions like that. Okay, so 6 is not prejudice. It will go to everybody. It's not just times the 2/3 and done. Minus 6 times 5 is 30 over 6 minus 18. It's the whole kit and caboodle. Distribute here, 6/2. 6 times 1 is 6 minus 30. And again, the 6 is hitting everybody. So now you're going to see why 6 works so well, because this becomes 4x minus 5x minus 18 equals 3x minus 30. So we took a problem that looked crazy hard. We did one step and we're back to problem number 1. And in fear that I'm going to screw this up, I'm going to let you do it. And someone's going to give me an answer. I get a 3. Redika says 3. Am I saying that right, Redika? Nina says 3. Everybody says 3. All right, I'm going to keep going and see if I can. I'm now going to add 30. And it looks like I get 12 equals 4x. Divide by 4x equals 3. Yeah. I have a question, folks. When you're doing work at home, does it, as you can see by what I'm doing, I use blue and red. Does that make it look a little easier? I've found over the years, students that use multiple colors, like doing the example I'm doing here, they found it's easier to follow their work if they look back through it. You know, and I think it sort of jumps out and helps out. Okay, let's see what else we got. All right, let's try oh boy. We're not going to do all these, but let's pick 1 or 2 and see what we can do. 5, 6, or 7. 5, 6, and 7. Which one do you want to do?
5.
5. Off you go. I'm going to do it at the same time, but I'm going to go 2. So I took care of the inner parentheses on the left side, took care of the parentheses on the right side. Two is distributed away. 2's going by everybody. Uh-oh. What happened?
We're going to end up having to divide by 0.
Yeah, if I add 8x and add 8x, I get a whole 28 equals 28. That's not so good. What's the answer here? Somebody says 1. Now, 1's not going to work.
Would it be undefined?
It's,
Because we
yeah,
can't.
we're going to go with undefined. And we're not going to see this very often, but it will happen. We're going to get undefined. We're going to get no solution. You can put anything like that you want. So we are going to have cases where everything cancels out. And it's going to be like, okay, yeah, that's not going to work. And up at the top here with the notes, you start to see we're going to have, and there's terms, and you don't really have to memorize these, is true for some values, which we just saw before, is an identity, which means it's true for everything, and then a contradiction where it's never true. So undefined, no solution, excuse me, there, we're going to do those interchangeably for our class. Okay, so the most common answer would be no solution. Want to do one more on this page? Which one, 6 or 7? This is the one thing I miss about the classroom. 6 it is. I fire names out quicker, and here it gets hard because then I have to wait for you to unmute and remute and unmute and so on. And Ryan said 6. Ryan's probably halfway done with 6. Mm. 6 is looking an awful lot like 5 did. Distribute that 2. Mm. 28 minus 4x equals 28 plus 8x. So far, so good? Uh-oh, I got an answer of 0. Is that okay?
Think so.
Yeah, that's okay. That's okay. You know, yeah, that's okay. 0 works. 0 is a number. I can plug 0 in, just like a negative and on and on and on and on. So that's okay. That's all right. That's okay. Don't get panicky. When is 0 bad in a fraction? Not up here. If I don't have any money and I divide it by 12 people, none of us have any money, kind of deal. Am I allowed to divide by 0? What happens if I have 0 down here? This is where that terminology comes into play of undefined. Why? Well, if I did this, if I said, look, yeah, now we don't want to get into that. We'll let that ride. Okay, good. Next page. See what we have over here. Okay, this is something that we were talking about. We were talking about earlier with, I can clear the denominator, and I need to figure out what I can do to both sides to clear that denominator. And I need something that's going to cancel with a 4, with a 2, and with an x. So for this problem, I'm going to multiply every term on both sides by, drum roll, Answer? Blurry, yes. I'm going to multiply everything on both sides by blurry. No, yeah, thanks, Ryan. A 4x. So I'm going to multiply left side, right side by 4x. And I'm going to, you'll speed this up as you go, but I'm going to do the multiply. 4x times 9 is 36x over 4 minus 4x times 1 is 4x over 2x. 4x times 4, 16x over x. Why did I choose 4x? Because if you look, this 4 and this 4 are basically going to cancel each other out so that I'm going to be left with 9x. 4x, when I put it here, I cancel with 2x, and that's just going to leave me with a 2. Over here, you're going to see the x's cancel, and I'm just left with a 16. So I need something that'll cancel with 4, 2, and x. So I'm looking at my denominators of 4, 2, and x. I'm going to add 2. This time I'm not writing plus 2 on both sides. Some of you still do, some of you don't. I'm going to divide by 9 and I get x equals 2. And we could fire that in there and check it. Questions on the number 8? Good. Number 9. Uh-oh. This guy is now a whole thing. It's not parts. When we look at a whole thing, 4 is a whole thing. 9x is a whole thing. Y plus 2 is a whole thing. So keep it whole, okay? Right now, I can't do anything with it. It's actually called a binomial, and I can't touch it. Hammer time. Can't touch this. Hammer time. Nobody? Daniel, do you know who hammer time is? No. So what am I going to multiply everything on both sides by? Are we back? Are we back? Okay, because I think I froze up. So now I can take these binomials and cancel binomials. I can cancel the binomials. I know some people like to do this. X plus 2 over 2. Let me cancel the 2's. No, you can't break up a happily married binomial. They're happy together. X plus 2 is a binomial. No, don't do this. No. Back over here, I'm left with just an x. I come in here. I have minus 2x plus 3. And now equals 3. And what's going on with this? We're back to problem number 1, right? A nice linear equation that I can solve. I just had to take this guy. He was called rational because it's a ratio. It has a top and a bottom. And I'm going to let you finish it from here. Tell me what the answer is. Somebody said -3. I'm going to say nope.
I got 3.
You have +3? Nope. Let's see, this becomes -x. Olivia says 3. Nope. Y'all are starting to think I'm crazy. 9. Nope. Is my work up to this point good? I canceled all that out. I have x, yeah. I have -2 times that binomial x plus 3. binomial, bi has two terms, and I have 3. I distribute the -2. I get -2x minus 6. Looks like I'm going to add 6. Maybe I did do it. Maybe that 9 is right. -x equals 9. How do I get rid of a negative? Multiply both sides by -1. I got x equals -9.
What happened to the -2?
Well, here the -2 gets distributed. Goes to here and it goes to here. Okay, it comes from right there. But I messed up again. You people, this isn't supposed to be x. What's this supposed to be? Anybody? What's that supposed to be? I took x plus 3 times the first. This was supposed to be x plus 6. Somebody say, ugh. Let's see, I'm going to take it over here. Now I'm left with that x plus 6 minus 2x minus 6 equals 3. Maybe this isn't a recording I want to save and display. Does everybody see where I messed up? That should have been x plus 6 times x plus 3. X plus 6. All right, I'm going to do the work. -x 0 equals 3. This comes up as an answer of x equals -3. Okay. So the purpose of this problem was to get to this answer, which is one that somebody said x is -3. But the problem with x equals -3 is if I bring it back up here and try and put it into my original problem, what's my denominator become?
0.
0. And am I allowed to divide by 0? And again, the answer is no. And real quick, if I say 0 times 1 equals, what's 0 times 1? Say 0.
0.
0. What's 0 times 2? That's also 0, right?
0.
Well, if this equals 0 and this equals 0, these two guys equal them. They're equal, right? They both equal 0. And watch what happens in math if I'm allowed to divide by 0. I'm left with 1 equals 2. That's a big no, right? That's a big no. So we're not allowed to divide by 0. And I'm going to jump down to number 13. And this is again, we're just working with x's and y's. It's boring as can be, but this is some things that you're going to have to do eventually throughout math. And that is solve for a given variable. Okay. And I want, in this case, solve for y, which basically says we want to end up with y equals. Okay. So I want to get the y term alone. I'm going to start by subtracting 3x from both sides. And then I would divide by -5 here, by -5 there, and I'd solved for y. 10 minus 3x over -5. Okay. Solving for y. This first one was solving for x. Same kind of deal. 13, solve for z. This is where the question we had earlier by Radhika, I want to get rid of the, so right now I have a equals 3/2 z plus 1. And I want to get rid of that 3/2. So I'm going to multiply this side by 2/3 and this side by 2/3. 2/3 times 3/2 is 1. So now I have 2/3 A equals Z plus 1. And again, I'm solving for Z. I want to get it alone. So now I'd subtract 1 from both sides, and I'd get an answer for what Z is. Questions? So this problem number 15 is more of what I'm talking about. You know, we may be asked to solve for C or to solve for H, or we may be given, again, it's an equation and I need to solve it. Adele's 2012 Mini Cooper died on the highway. No, gets 37 miles per gallon on the highway, 29 miles per gallon in the city. The amount of gas she uses, see, these are a little bit better variable names. A for amount, I probably would have used G for gas. C for city, H for highway. Okay. Question is, how many highway miles did she drive? Let's see, how many highway? So that means I need to find out what H is. I know what A is. A is 58. I know how much gas there was, even though that's A. So I'm looking at doo-doo-doo-doo. Doo-doo-doo-doo-doo. 58 divided by 29. Anybody? Bueller. Bueller.
Two.
2. Thank you. I made a little side note. 137 times H is really the same as 37 over H. So we can use those interchangeably. Next step quickly is to subtract 2. I want to get rid of that denominator. My denominator is H. So just like I did with a regular number, I'm going to multiply both sides by that. Over here, they cancel. 5H equals 37. Divide by 5. I get H equals 37 over 5. Question was how many highway miles? 37 over 5 miles. Yeah, you know how to convert that, right? Right now, it's what they call an improper fraction. We need to make it a mixed numeral. 5 goes into 37 7 times. The remainder of 2, 7 2/5 miles. Questions?
What happened to the 2 there? Wouldn't it be 3 since we subtracted the 2?
Holy cow, my brain is asleep. Yeah, when we subtract 2, that should have been a 3. That should have been a 3. Huh. People here are laughing at me in the background. That's a 3rd strike for me. I'm out. 36, H equals 37 over 3. That equals 12 1/3 miles. Who corrected me? Was that? I don't even see who it was. Who caught that?
It was me,
It was me.
Nina.
Nina. Thanks, Nina. 1 bonus point for Gryffindor, thanks to Nina. See, I'm a funny guy. My students don't think I'm funny. They're not laughing at all my jokes. They're all into this math stuff. Thanks, Nina. Do. Stop sharing. Okay. There we go. Ta-da, there I am. View. I'm going to go back to gallery so I can see everybody. Nicole. Nicole, are you new to class? Nicole. She's not going to answer me. Nicole, I see you're here, but I don't see you on my list. Did you add late? She's not.
Hey, Professor. Sorry, I don't know why it's signed into my mom's Zoom, but
Oh.
this is actually Peter Cambyses, and yeah, I signed up a little late for your
Okay.
class.
Well, your mom can come.
So
to
I'm not
class.
Nicole.
Your mom can come to class if she wants. That's fine. You're Peter, and I'm going to mark you as being here. And I need to update my attendance sheet then. But okay, yeah, I'm glad you made it. Hopefully you got some of that. But all right, I'm going to stop there just because I've screwed up 3 times. 3 strikes, I'm out. We're going to end class. Between now and Thursday, you are going to get on Alex. Nina, if you can't get on because of your cookie problem, oh, Nina, don't yawn. If you're gonna, yeah, you need to get on Alex and make sure that works. And come with questions on Thursday. We're gonna start right in with 1.2. So my good students who really want to do well in this class, they're probably gonna download that 1.2 and see how much of it they can do ahead of time, right? So yes.